they do come outside. So this process is nothing but called as a photoelectric effect. It's called as a photoelectric effect. So what is the photoelectric effect? Photoelectric effect is one, whenever the ultraviolet radiations are falling, the electrons, the free electrons from the metal surface, they do come outside. From the metal, they do come outside. And these are nothing but called photoelectrons. Photoelectrons. So this phenomena in which ultraviolet radiations falling on the metal and free electrons are coming outside of the metal, so that process is called as a photoelectric effect. So now we can define photoelectrons. When light of suitable frequency, here the light is falling on the metal surface, so very important is frequency of the radiation. So when light of suitable frequency fall on metal surface, then electrons are emitted from metal surface. These photo-generated electrons are called as photoelectrons, and the process is called photoelectric effect. Now, to study experimentally the photoelectric effect, we need to have an evacuated glass tube. In this glass tube, we got the two metal plates. One metal plate is made by the photosensitive material, the red color one. So that is made by the photosensitive plate. It is a thin photosensitive plate on which the radiations from monochromatic light falling on it. And we have here the quartz window. Window means it is a transparent material, so that the air should not come inside, but the light should able to come and fall on the photosensitive plate. So that is a quartz window. Whenever as soon as the radiations fall on this photosensitive plate, the electrons are emitted. The electrons do come out of the metal surface, but they cannot travel to other end of the tube. What is the reason? The reason is that they don't have sufficient energy. Therefore, even though the electrons do come out as soon as the monochromatic light fall on the metal surface, the electrons are not able to travel to the other end of the tube. The reason is that they don't have sufficient energy. What we should do to impart the energy to them? Now what we do? We connect a commutator across this glass tube. For that, we are connecting end of the tube with the help of a commutator key. This is a commutator. What is a commutator? Commutator is a device by which you can change the direction of current. You see here the commutator, here is a like speed breaker symbol. What is this is a jumping. That is called as a jumping. What is the jumping? Jumping is nothing but two wires are crossing one over the another, but there is no electrical conductivity like this. This is called jumping. Here are the two wires and here is the jumping. This is called jumping. So here now these are connected to a potential difference. For that we need a voltmeter is connected so that we can measure the value of voltage, and it is connected through a rheostat. And now a cell. We are connecting a cell now here. So we connected a cell. Here now the emitter is missing, so I am now connecting emitter here. Micro emitter is connected here, and this is the EMF source, plus and minus, and this is the commutator. So here one is a plate C and plate A. Let us call plate C as a emitter and plate A as a collector. Now what is the use of commutator? Commutator, by using the commutator we can change the polarity of plate A and the plate C. So polarity of plate A and the plate C can be reversed by use of commutator. Here I have removed the applied potential difference. I have removed the EMF source. So we find that the photoelectrons are emitted at the plate C, but they are not able to travel to the collector plate A. Now as soon as the suitable potential difference is applied between the emitter plate and collector plate, these photoelectrons ejected from the emitter plate travel up to the collector plate. So what is the purpose of the EMF source? The purpose of EMF source to impart energy to the electrons, emitted electron, so that the electrons do travel from emitter plate to collector plate. So EMF source is helping the electrons, helping the photoelectrons to travel from emitter to collector plate. The job of the EMF source not to emit the electrons. The job of the EMF source to help the electrons to travel from emitter plate to collector plate. Now the emission of photoelectrons